Everyone, welcome. This is a video from my Algebra 2A class for the week 12 Desmos activity, practicing with inverses. So this last week, we're going to end the first semester looking at inverse functions. So we've been doing linear functions, quadratic functions, polynomial functions, radical functions. But now we're going to think about this idea of an inverse function. An inverse in math just means it's the opposite. So if I add, that's an operation. The inverse operation is to subtract, because subtracting is the opposite of adding. However, we have an inverse function. In other words, a function takes an x value, turns it into a y value, input, output, right? The inverse function does it in reverse. It takes the output value and turns it back into the input value you started with. So we're going to learn how to work with inverse functions, recognizing inverse functions, and thinking about graphs and equations and the relationship between the two. Okay, here I am on the first slide. Find 3 points on the graph of the inverse function for f of x, and then find the equation for the inverse. So here I'm given, I can see I've got f of x equals the cube root of x plus 4, and there's some points I'm given there, right? I can see the points on the graph right there, and the function that goes through. So find 3 points on the graph for the inverse. So the inverse is the opposite, or it takes the output and turns the input. So if I start with 0 and it turns into 4, the inverse function is going to start with 4 and turn back into 0. That's what it means to be inverse. It's the opposite. So there's 1 point that's going to be on the inverse function. And now you probably already guessed that yes, all the other ones, if I know 1 and 5 is a point, then 5 and 1 is a point on my graph. Let's put that in there, and then 8 and 6 means 6 and 8. So there we go. I've got 1, 2, and 6 and 8. Oh, it's up here a little bit. Let me shrink out. Right there. There's my 3 points on the inverse function. Okay, now I need to think about how do I find the whole entire function. So this is my original function. I don't have my pen plugged in, but I can still kind of show you a little bit what we got going on. Let me take this function, let me copy it down here, and we'll just algebraically work it out on the side here. I want you to do this on paper, but I can't really show you my paper in a video. So there's the function we're going to work with. I'm going to turn it off right now. But to do the inverse, I need to think about y and x and how they're related. So we have this function. Let me replace it with y right now. And if you think about it, the inverse function is just the function that takes the y value and turns it back into the x value. If you look at the relationship with my tables, all we've done is flip x's and y's around, right? Instead of 0, 4, we have 4, 0. So I find my function the same way. I take the original function, and the first thing I do is I switch x and y. So I'm going to make this, instead of the cube root of x, it's going to be the cube root of y. Instead of y equals, it's going to be x. So there, x and y are switched around. Now I still need to solve it. I still need to solve it for y and then put it into function notation form. So I got to do some algebra here. So I got to get y by itself and get rid of the plus 4 and the cube root of 3, or the cube root. So I'm going to first subtract 4 from both sides. And when I do that, my function becomes x minus 4 equals, and I still got the cube root of y, but the minus 4 and plus 4, those cancel out to 0. So there's my first algebraic step, subtract 4 from both sides. Now I still need to solve for y, so I need to undo the cube root. And to do that, I take both sides to the third power. I'm going to use my parentheses and take it to the power of 3. Which means I then have to, on the left side, take it to the third power. So there's my parentheses there and to the third power. So what do we have now? My y, cube root and cube, I got y by itself, equals all this stuff on the other side. X minus 4 to the third power. So now I've got a polynomial, right? An x to the third, a third degree polynomial. And I can now replace the y with f of x. And let's turn all this off, but let's look at what we got. Here's my original function. Here's the points that we found on the inverse function, points on the table. And here is our new function that we found. And yes, it does go through all three inverse points. So highlighting it, again, if you have a table, you just switch your x and y values around. That's the easiest way to find an inverse points. But then to find the inverse function, you have to do a little bit of algebra. Switch x and y around, and then do all the steps to resolve the new equation for y. And that gives you your inverse function right there. All right, you're going to kind of keep working with this, working with other different functions. It gives you a function, it gives you a few points, and you're just going to practice over and over again finding inverse values and inverse functions. Let me know if you have any questions. Hopefully you have a pretty good idea of what the inverse is after this.